And Angela, take it away.
Thank you. Good morning, everyone. Welcome back to FMForward 2021. Today, I am your host. I'm Angela Rothmich-D'Amato and the current IFMA Boston president-elect. Let me start by saying that the work we do at IFMA Boston to be the expert resource for facility managers in the Boston area could absolutely not be done without the support of our annual partners. Their funds each year go directly to underwriting our programming and allowing all of our members to attend for free. So please show your thanks by visiting them in the rooms within the community, by answering questions in their polls, questions, and cheering them on in their posts. We would also like to thank Corporate Care, Fort Point Project Management, Margulies Peruzzi, Timberline Construction, and VVA Cost and Project Managers for their help in underwriting this year's conference. We will have several breakouts within each session today with moderators. If you happen to find a room without a moderator, please elect a scribe. And for all of our FMs, we will be discussing the topic further on our FM overtime session in a special Zoom at the conclusion of this gathering. If you don't have the link, just do a private chat to Janessa during our talk and she'll send you the code. Okay, let me introduce you to today's speakers. Today we have Gary Mignall of Phillips Academy and Michael Oldham of Meridian Associates. Take it away, gentlemen.
All right, good morning. Thank you all for coming. There we go, we're working. So Gary and I are here to talk about geospatial technology for better facilities management. So the partnership here is between Phillips Academy in Andover and Meridian Associates. We're at a small engineering firm out of Beverly, Massachusetts. We've worked together a few times. So the presenters are myself, Gary Mignall, who's the Senior Capital Projects Manager at Phillips Academy, and John Ings, Vice President here with Meridian Associates. And the kind of learning objectives, outline, flow of the presentation today are, I just want to introduce some geospatial technologies that we've used and have been used for facilities management. Now, geospatial technologies ranges from GIS to satellite images, and we're just going to focus on a few that we really know. And then we're going to highlight this with a case study of how we've deployed these on Phillips Academy campus and how it's helped. And then with the ultimate goal here of just connecting the dots between some of these new tools and what you're doing in your facilities in hopes that you can connect the dots and follow in Gary's footsteps here in blazing a new trail. So I'll hand it over to Gary to set the stage for how he manages his large and sprawling campus, and then how we worked together using drone imagery to benefit the campus. So, Gary.
Morning. Thank you, Michael. Morning, everybody. As Michael said, my name is Gary Mignall, and I've been employed with Phillips Academy as a senior project manager for 35 years. And the campus is basically one of the oldest prep schools in the country. It was established in 1778, currently around 243 years old. It sits in the heart of Andover. And it comes about 450 acres of property with 170 buildings to maintain. The campus is about 80% historical. The school has frowned for many, many years to maintain its historical nature. The building sits in the heart of what they call the campus historical hill. So all of our buildings are pretty much governed by the Andover Historical Commission every time we do work on them. So very important buildings, mostly made up of slate roofs with brick facades. So the campus is, as I said, a private prep school. It admits about 1,150 students a year, which being some domestic, and we also have a big international program. The school employs 300 faculty members who all live on campus. And we also have 300 administrators along with facility maintenance folks. So roughly around 600 employees run the academy. Today, my focus is on one of our historic buildings and one of our most important buildings on campus, and that's our central heating facility and power plant located off of School Street. The building is a very vital building, and it provides 4 essential needs for the campus. First of all, the building brings in about 36,000 volts of electricity via national grid. And we transfer that power through a switchgear, and we send it out to 12 different zones on campus underground grid system to feed power to about 60% of our buildings. The other piece of the power plant's initial objective is heating for the power plant. We run 3 fairly sized Johnson boilers during the winter months to generate steam heat that also feeds about 60% of our buildings in 5 miles of pipeline. On the way out the door, we send that steam through a steam turbine, and we produce some electricity that basically runs the power plant, and we put the rest of it in our grid system. So if you're going to produce the steam, you might as well use it for other purposes. So the steam turbine, during the winter months is a great asset. The final piece of maintenance that plant provides is we have a 3 meg generator that powers up emergency backup power to about 50% of our main buildings. So if National Grid was to go out on us, we have the capabilities of providing backup generation for that service. And the big focus today is on our 189-foot chimney stack, which is a vital piece of equipment that pretty much exhausts all of this technical stuff that I talked about. Without this stack, we would be out of business. So one of the things we try to do here at the Academy, and one of my biggest focuses, is I look at long-term maintenance issues. I look at renewal budgets, improvement budgets. I'm involved in design of new construction, old construction, and pretty much, I develop budgets for year-round estimates of what deferred maintenance is going to cost, and we get that generated into a spreadsheet, and we send it off to the trustees every year, and they vote on a budget to maintain the campus. We look at the priorities that have to be done, and one of the biggest priorities is to maintain the power plant. So the chimney stack, we take a look at the exterior of that chimney stack every 5 years. And over the years, these chimney companies are starting to deplete. There's not a lot of them left around here. So it's kind of a dying trade for these guys. And they're very costly when you retain them to do this work. So the old way we used to take a look at the chimney stack is what you see on the screen is the tower company would come in and they would erect 2 stagings, wenching stagings. That process would take about 2 weeks to develop. And then you have the workers wench their way up through the stack, and they start to gather information of porous joints. They look at scissoring cracks in the brickwork due to expansion and contraction. The stack generates a lot of heat on its way out the door. So a lot of condensation gets built up on the internal side of the stack. And with the joints deteriorating on the outside and all the scissor cracks in the brickwork, you start to retain water on the outside every time you have a rainstorm. And you get the freeze thaw conditions, which expands and contracts the stack, causing a lot of damage to it. The steel belts that you see around the stack, there's 32 of them. Those have been applied to the stack to try to maintain, not so much to stop the expansion contraction, because you're never going to do that, but it kind of helps hold the stack in place when expansion and contraction does take place. So the exterior of the stack, the biggest things for me to look at, we do a 5-year inspection. I'm interested in, serious cracking in the brickwork, we definitely look at all the mortar joints. It's very important to make sure that the mortar joints are not deteriorating to allow more water and moisture to go in. And we also look at the belts, the steel belts. They take a lot of tension over a 5-year period. With the expansion, when they expand, they tend to spread out a little bit and they loosen up. So all those turnbuckles that you see, we try to put those on a 5-year schedule to get those tightened back up again. Or what will happen is some of the steel belts will actually slide down the stack and fall on top of the one below it. We actually had some of the rings snap right in half from the pressure. So just recently we replaced all the rings. They're only about a year old right now. So conventional wise, this process to get the inspection done is a job in itself, and it's very costly. So the company would come out here, they'll erect these 2 stagings. Takes about 2 weeks to put it together, barring you have good weather. And then the process to winch those platforms up and down the stack usually takes about a month to a month and a half to complete. And then there's a process of waiting for that report to come back. That report could take about 2 months before the company will generate a report from everything they've seen and send that to us. And then you've got to plan on what the deferred maintenance is going to be based off that report. And then we get it budgeted, and then for the next 4 years before the next study of the tower is due, we just try to get as much of the maintenance done as possible. So one of the focuses that we were looking at recently, we had a lightning strike on one of our aristas at the top of the tower. You'll see these antennas sticking up. We have a lightning protection system that protects the tower. And we believe we had a lightning strike last year that separated the ring that formulates around the top of the cap. And one of the aristas actually got broken right off. And we know it's going to be a very cost-effective thing to get it fixed. We were concerned about the cost of staging this thing, as you can see, to get the work done. We thought that was going to be a lot more than it was worth. We've tried other applications to do work on the stack. We brought in a 200-foot crane with a swing bucket, and I've been up there, and unfortunately, the wind velocity at 189 feet is a lot different than the wind velocity at ground level. So if you're at, if the wind is blowing at 5 miles an hour down below, I mean, you're at 30 to 40 miles an hour at 189 feet. And that swing station and that crane is flying all over the place, and there's no control. And you really can't get a good look at the stack with that happening, because you're probably holding on to dear life so you don't get tossed out of the bucket. So we kind of got away from doing that. We thought it was too dangerous. We didn't get a good look at the tower with the swing crane. This process that you see on the screen right now is like I said, it's very time consuming. It's very expensive. So I was researching another program that we had done with Meridian Associates a few years ago. We had them come in and do a kind of a pedestrian traffic plan for us on Main Street in Andover to look at our main campus throughway. We were having issues with students crossing over the main highway, getting hit by cars, and the campus powers that be got very concerned that we had to change some of the foot traffic and the way traffic flows through campus. And so Meridian had come in and was working with one of my other managers to develop a new plan for pedestrian walkways. And during that process, they used the drone to do some overhead projections of the roads and looking at how traffic was progressing and different times of the day. And they did a whole program on it. So last year I was looking at that program, and it kind of hit me that I was wondering if there was a way to use the drone to get a look at the chimney stack. Because basically all I really need is to know what the stack is doing. I don't need a company to come out here and tell me, find the information out, put it in a program for me, and then I can develop an estimate. If I could see what the stack looks like from 189 feet down to ground zero, I can pretty much develop my own plan of what has to take place. So I contacted Meridian, and during a period of 3 or 4 months, we discussed it, and we decided to come out and try it out. And unfortunately, the first day that we went to do it, the wind was about 40 miles an hour at ground level, so the drone could not get beyond a halfway mark. The wind was blowing the drone all over the place. So we scrapped that day, and we came back on another clear day where there was no wind velocity. And amazingly enough, the drone worked unbelievable. I mean, we were able to generate over 100 photos of the stack. We looked at every angle. We looked at every turnbuckle. We looked at all the lightning protection system. It gave us a really good look at the brickwork, the masonry joints. We saw cracking. We saw bands that were loose that had slid down a little bit, that were not in their position originally. So it gave us a good look as to what we needed to do to put a maintenance plan together to generate a budget, so that over the next couple of years, we can build that in over time. And it gave us a look to do the essential things first. We got a great look at the damage that was done to the lightning protection system. So over and all, it was a very, very good project. It's something that really enlightened me to look at other ways to use Meridian, to look at some of our taller buildings, roofing conditions and brickwork on larger buildings that, you can't get a lift near, or, you don't want to stage these buildings because of the cost to stage it. Just to get maintenance information is expensive. You could use aerial lifts, but the problem with that is some buildings you can't even get near the buildings with the aerial lifts. So the drone has been a great tool, and really in moving forward in modern technology, I would highly recommend it for anybody that's in a facility management business to gather information on their buildings. And if you don't have the expertise to know what you're looking at, just to get the information on a snapshot. There's companies out there, building technology companies that you could hire. You could use these photos with them to generate a maintenance plan if you don't have anybody that is familiar with what they're looking at. So there's a lot of ways that you could save a lot of money doing this, rather than having a company come out here and stage the entire tower and take months of time to generate these maintenance projects. So that's where we ended with Meridian. They've been a good company to work with, and I wish them the best of luck in the future. We've talked about some other ideas that I'd be interested in looking to research into, and they have their general knowledge of future technology at their grist right now. So I'm very impressed with them.
Awesome. Thank you, Gary. I think the biggest takeaway, so Gary explained the complexity, all of the moving parts on the campus, the complexity of getting this tower inspected. And drone inspection is high tech, but I think the coolest part about this project that Gary kind of said too is just actually the simplicity of it. We just took pictures, and Gary knew what he was looking at, so they were useful to him. Like, this isn't some fancy products that you need a lot of software and a lot of expertise in drones or remote sensing or to use. We just gave him photographs, and he used his 35 years of experience with this tower to put the pieces together. So that's, from this case study, that's my biggest takeaway, is just use the technology there, but use it for your needs. So yeah, get a drone up in the air and take some pictures. See what you get.
Yeah, Michael, one of the things that I did fail to say is that the process that it took to get this information took about roughly around 4 hours to fly the drone around the tower. And I got generated pictures back in 2 days. So I was off and running with building a maintenance plan for the budget almost in the same week that I got the information. So much better than the conventional way we were doing it. So big time saver.
Excellent. And also with drones, so every 5 years would be the traditional revisit inspection. But as Gary said, it takes about 4 hours. So if tomorrow there's something else that needs to be looked at, we can be out there and grab those images. So it's on demand. So it's cost effective and eliminates a lot of lead time for these inspections. So I think kind of early, but this kind of sets the tone for the rest of the presentation. We're going to go out into a breakout room and just kind of build off of what Gary said about how he builds his management plan, how he informs it, the different means and methods, and then focus on some, one complex point in his infrastructure. So in the breakout room, if you guys can just brainstorm about how you put this together yourselves, who's providing you this information? Is it even just, this is how we've always done it, or John noticed that the window's broken, we got to fix that. Information comes from everywhere. And then also, if there's one specific point that is pretty a hazard spot for you. So I don't know how these breakout rooms, the logistics of these go.
I will put everyone into rooms. Everyone should have a moderator in your room who has the questions. For our speakers, you will get invited to the room. You can decide to stay here or if you want to go. So here we go. And Michael, how long would you like them to be within their room?
7 minutes.
All right, we'll see you all in 7 minutes. And let me just go for it.
All right. So hopefully there was something to talk about. I don't know if anybody, I think 1 or 2 minutes, maybe bat around some ideas that y'all talked about. You can either speak up or throw it in the chat.
Yeah, this is Frank. So in our group, what we talked about, I'll hone in on probably the pain points. And one, I think we all could agree, it comes down to the financial constraints or the budget that someone may have in mind, and you're presenting that budget, and it doesn't necessarily go further than that conversation. But we struggle with a pain point, I think, from all of ourselves as FM leaders with the aesthetic versus the mechanical components, right? So whatever building you may be in, if we're selling that mechanical conversation, yet you have an enhancement to the property or the front of house, as we call it in the hospitality, that's always going to be some sandpaper conversation and some confrontation that you have to fight for.
Excellent, thank you. So are you, kind of the information you're getting from that, Frank, is that just organizational knowledge that you've gotten or are running with, or any?
I deal with it all the time, right? So I'm a regional director for Marriott, and I see about 150 capital projects or 50 capital plans, 10-year plans a year, and we review them every June. And that's always the battle, is how do we get our chiller versus a room's renovation, or how do we get an HVAC unit for our corridor versus a meeting room breakout renovation. So it's a lot of those conversations we have just internally before it even goes to the owner. So we tend to fight internal and external on a lot of these projects, and we have to go to bat of why. And if you don't have a compelling case, it makes it even more challenging to pass it internally before you even get to your ownership group.
Sure. So compelling case sounds like it's information driven, which is an excellent
So Frank,
segue.
I think actually as we move in, you'll see that we have tools that can speak to both of those things.
Thanks, John.
So yeah, so the information, like my screen is not asleep here. So now we saw the kind of geospatial at work with this drone inspection, point and shoot, and now we'll get into a little bit more different technologies and different uses. We're going to focus on the physical campus here and kind of in three kind of service areas of mapping and surveying, inspections, and 3D modeling. And we'll focus on aerial imagery from drones, LiDAR, which is a laser scanning technology, light detection and ranging, and then another form of laser scanning. And so we'll run through the product, the technologies themselves, and point to some deliverables, some products, and the information gleaned. So aerial imagery, it's more than just pretty pictures, although pretty pictures are valuable to certain sectors and aspects. We saw it in play in inspections. It can also be used for mapping, and the driver behind kind of these drone technologies are, miniaturization of everything. Every camera is fantastic now, and you can stick it on a drone and get high resolution imagery. And as we spoke on the inspection, the on-demand, you can just basically drive time to your site is your time. And so here's just another example of an inspection. We'll circle back to this project too, but this is a up-close building inspection for historical preservation, which is getting existing conditions on inaccessible places. This is an architectural firm was doing historical preservation, but we'll come back to this. So the other product from drone imagery, aside from just single image delivery, is a technique called photogrammetry. And so this is taking hundreds or thousands of images that are overlapping and then throwing them into a nifty physics machine that finds common points in them and extracts 3D information from it. So you can stitch all of these images together into one seamless image that gives you a bird's eye view of your campus or your building or facility or whatever you're looking at. But it also can extract 3D models and Pointcloud 3D data that I'll get into in a moment. So this is an example of the map making top-down imagery process. What you're seeing on the right side of your screen is that mosaic imagery. So this is hundreds, maybe 1,000 images all stitched together. And over here, you're seeing the flight pattern that we did, where each of these green circles is where an image was taken. So you can see right in the center here, you've got 10 or a dozen images that capture the same point. So that enables software to extract 3D information. And in this case, it's just two seamless orthomosaic. So you can see the value in this from campus mapping or inspection. And then this is an example of the same methodologies, just a little different product view. So you get the same top-down view of your full facility. And then over here is actually a 3D view. So this is a 3D model, kind of an oblique view from the side that just adds an extra dimension of information. You've got heights and distances and view sheds. And this can be pulled into any number of softwares, CAD, full information that you need. Here's another same process, same overlapping images stitched together. This is a rooftop. This is actually our our rooftop at our office. This was just a pilot study to kind of see how well we can dimension and grid out rooftop for rooftop solar. So if you're looking to add solar to your rooftop, knowing how much square footage you have to work, uninterrupted square footage you have to work, and with the high resolution imagery from the drones, we're able to identify, the standing pipes that are out there, all of the different features, we're able to dimension between it, and then you've got a good footprint for what you can do up there, as well as just existing conditions. That was a few of the just drone imagery products, and now we'll move into LiDAR. So again, this is light detection and ranging. It's a 3D laser scanning technology that just rapidly collects dimensions on its surroundings. And it can be, we've got a sensor here that can be housed on our drones, which this drone is what was used for the stack. It's, the little one you can get at Best Buy. And then this one is, 6-foot wingspan, basically a flying lawnmower. But then we can flip this sensor upside down, throw it onto a vehicle, and we can ride just to drive the streets and collect laser scan and imagery. And this will all, it'll make sense. I'll bring it back home. So just primer on LiDAR. It was developed as an aerial surveying technique. So you put this laser in the belly of an aircraft and shoot down, and it shoots the laser and measures how long it takes to come back. So you've got distance measurements. This a single distance measurement we call a point. It's an XYZ. It's got lat long elevation coordinates, so it's real world elevations. And the laser scanner can put out, ours puts out 700,000 points a second. So it's collecting 700,000 measurements every second, and then aggregated all these individual points together. We call it a point cloud. And you're kind of seeing just a little illustration of what this looks like down here in the trees. And so it collects the surface and works on line of sight. So you can see that it hits the ground, and then these points are colored by elevation, where the color changes with the height. But big point takeaway here is individual XYZ measurements, real world measurements, millions of them aggregated into one data set, and that's called a point cloud. And then so here is a visual of this point cloud being collected. Here, these red lines are the trajectory or the path that one was flying. So you can see we did back and forth missions, and then it's taking simultaneous imagery as the point cloud is being built below it. So again, this is colored by elevation. So these are actual measurements from the laser scanner, with blue being lower elevations and then going up to red. And as I hit play here, you'll see this is real time, just how many measurements are being captured as it's going down the street, or the side of the street. So you're seeing that it's capturing buildings, trees, surfaces, utility poles. And these are measurements. This isn't just a fun, pretty picture, although it is quite fun. And then here is, so that's the drone, and now sensors flipped into a vehicle. And this trajectory here that you're seeing is our truck's path through an intersection. And as I hit play, this point cloud is going to build, and you're going to see the whole intersection just kind of come to life in front of you. But so you're getting the ground. These are traffic signs above it, signs, curbs, trees, buildings. You've got the groundwork for an as-built survey in the time it took to drive through this intersection. And these are probably, 700,000. So this is probably 4 or 5 million measurements that were taken in, I don't know, 600 feet. And then, so the resulting, once it's processed, we can get something like this. This is a point cloud scene with the imagery that we collected laid on top of it. So you're just taking the images and the point cloud, lining them up spatially. So you're seeing what's there in kind of just a more realistic view. And I also just really like this picture. Did a good job on it. But this is just a pretty picture. And then bringing it into kind of the real world here, this is what you can glean from this, just one example. So this is a mobile scan that we did. And what you're seeing behind it is a CAD drawing, all of the information that we extract from this mobile scan. So you're getting your curbs, your buildings, your hydrants, your street monuments, your street trees, locations, heights, dimensions, get TBH on street trees, paints, everything you can see that's not obstructed has been captured and can be pulled. And then laser scanning is, so traditional laser scanning, this is another laser scanning device that sits on top of a tripod. So it's stationary, it works inside and out. But this is the highest precision and accuracy equipment that we use and deliverable that we can do, and actually anybody can do. But it's used a lot in building dimensionality and interior, especially for BIM modeling, building information modeling. So this is the tower that we saw the inspection images from. And I think it's actually just quite a beautiful image. But again, keep in mind that this is a laser scan. This is a dimensioned picture. Each one of these points is an XYZ measurement. And then this is a close-up of that clock face for the historical preservation project. So this is the point cloud itself. You can see how much coverage and detail is captured by this instrument. You're getting individual bricks. You can even see what time we did these scans at as these hands move along and are captured in different scans. And then all of this information can be translated into a 3D model that's used for building documentation or designing the renovation. So this drawing actually pulled out the individual stonework. Now the bricks we just said brick and added brick, but these are actually individual stones. You can see the seam line here and the seam line, well, it's there. So they know how many stones need to be replaced, conditions, because we've also got those images that we collected before. We've got the same high resolution imagery that you see from the chimney on this building too. And then this is an example from an interior scan. So this is another example of the point cloud being laid on top of the image. This is not just a cell phone snapshot here. We're actually inside of a scan. It's kind of like a snow globe of 3D information that you can spin around in. This is just a still, but you can see the detail captured. And again, I'll emphasize that this is a point cloud that you're seeing. You've got coordinates, dimensions on all of these pieces and the context. You see which pipe runs into which pipe, where it goes, how it interacts with I-beams. So you can do flash detections, and then 3D modeling from this too is here what you're seeing kind of the point cloud laid over what has been modeled out of it. So we're taking all of this busy information and extracting just what's pertinent to the client. So you're seeing the pipes and the valves and the beams and how they're all interacting and positioned against each other. And another, I don't have an image here, but another big thing is for kind of office renovations where you can bring the laser scanner in and dimension a full floor of a building if you want to do renovations or just modeling of what you have. You know, with the potential transitioning of office spaces as we move into 2022, that can be some useful information to have. So I just kind of burned through a lot of information and showed a lot of pictures. I don't know if there's questions that we want to take kind of right now. I just got a burning question.
Yeah, I do.
Yeah.
Do you do internal piping such as sewer pipe or anything of that nature from a scanning perspective? And then also, are you doing the facade inspections for Boston with this technology for our properties or commercial real estate?
So I'll start with the kind of underground utilities. They can be, and we have done scanning. So basically you'll take that field scanner, and now it's traditionally sitting on top of the tripod. They'll just flip it over and drop it down into the manhole. And so it does the same scanning down the channel. And then you can see all of the inlets, outlets, and you've got the same dimensionality.
Is there a size constraint?
To the scanner itself, there are scanners can be this big to this big, so it depends on the site specific.
Okay.
It's a depth constraint, Frank.
Okay.
If we put it on a pole,
yep,
and if we go down too deep, the laser spins, and if it spins too far down on the length of a pole, it will wobble, and
okay,
the information wouldn't be great. In that situation, and that's a situation where we're trying to stay out of confined space.
Yep.
But if we had to, we could do the confined space entry, work through all of that, that situation, and take the scanner down. So from top, there's a constraint on depth, but then we can deploy different means and methods to get to that depth.
Okay, thank you.
And also I wanted to mention, if you're inside the building, that sewer pipe would just be another pipe, which if we can see it, we can scan it.
Okay. Okay. I'll connect with you afterwards.
That's actually a great point on the confined space rescue, especially, well, the confined space, if you need to get into an area just to check the inspection. I didn't even think about that. I guess I just have a couple of questions. So I think it's really interesting, really cool technology. And I guess is it kind of like a flat rate, is like a cost per day for, I guess, I don't even know, what do you call it, the pilot or the end user? I'm not sure if there's like a license or a permit requirement for this. But is it a kind of a cost per day for you guys to do the inspections? And then does your team do or produce the inspection report, or would you say partner with an engineering firm to show them what you're inspecting, and then they'll write the report?
So the answer to the first question is, we typically try to scope each job because we find that, as in Gary's case, for us, it was flying the drone and producing the pictures. There was no dimensional work that we had to do. We try to look at each project. I think part of the answer would also be if there's a repetitive process that you want to do, we could probably put a day rate to that. But we try to scope each and every project appropriately. And then what was the second question? I'm sorry.
That makes sense. I guess just in part of like the reporting, do you guys do some of the reports as well, or just partner with another firm?
So it depends. If it's something that's that we're subject matter experts in civil engineering, landscape, survey, we would do the reporting on that. If it was, I'm not a mason, so I wouldn't begin to try to tell you how to take care of your masonry. So in specialty situations, we would provide the information to another party, and they would do the reporting.
Got it. All right. And then I guess when you guys kind of tapped into this market, do you guys go to like an open field to start practicing on how to kind of remote control and drive these things, or is it crash course, no pun intended, take it out for a test drive and hope you don't crash into a building in the surrounding area?
So unfortunately, the answer to your question is yes, we've had a learning curve. I'll say it that way.
Yeah.
But also it is, we have pilots on staff and they are Part 107 FAA licensed. So there is a licensure, and depending on where we're flying, there's different waivers we have to get. We can't fly over people. So if we were to do that, we would need to get a waiver for that. So there's a whole process in actually launching the drone.
Cool.
But if it's not within an airport 5 miles, it's pretty much up to the pilot. And when we're within 5 miles, it's a process of going and getting FAA clearance.
Got it. Cool. Thanks, John.
So, Michael, we have about 6 minutes left. We will have the FM overtime for everyone to come and continue to ask questions there. How do you want to use your last few minutes?
Well, I think if there are more questions, we should just keep rolling. I'm going to go out into a breakout room, but I think everybody can think if there are questions, we should stay here.
Perfect.
Hopefully there are questions.
Yeah, now that we go up for that, like, oh, it's going to be totally quiet.
Yeah, no, I mean, this is Andrew again. I'll ask one more, and I think it may benefit others depending on the size, how tall their building is. But I think one area specifically where this could have, and it gets actually to the stack where you're looking at either repointing or whatnot, is kind of the city ordinances on facade inspections, where typically, whether it's a window washing rig or window washes, and you're spending a lot of time and effort and labor for inspections and getting over, just going through the detail of whether, hey, is it 10 stories, 15, 20 stories, trying to look for any cracking or spalling in the building. This is something that I think would add a ton of value, where you can do the inspection report pretty much from the ground, take the pictures, the engineer can then go back and provide the report. So I think the technology is actually really good. It's probably something we'll see more often in the future.
To that point, Andrew, we've actually talked to people that do glazing. And again, as Gary sort of used the technology, we can put the drone up and take a picture and even do video. And in that situation, the glazing technician is right there and is telling us what to capture and where to look. So that's sort of answers the other question you had. We wouldn't know what we were looking at if we were looking at a window, but we had the technology to get the visual, and the other person was doing the inspection shoulder to shoulder.
Nice.
Today it would have to be 6 feet apart. We could set up another monitor, but
That's really cool.
And the value there is the property owner knows whether or not they should go further, and all they've paid for is the drone and the technician to be there.
Great, thank you.
And one of the things, while you guys were in the breakout, we were talking, I was asking about the traditional way on the Phillips project, and Gary noted that it was so much quicker to get the turnaround, but it was about, he paid 10% of what he paid in the traditional sense, and being able to, it was clearly a much less expensive, but also that then gives you your ability to do it in a more frequent sense, especially in these historic ones where, it used to be 5 years, but a lot can change in 5 years. So I think that's another benefit.
So what are some of the resolution on these cameras? I mean, how fine of a picture can you get on a window or when you're flying?
So there are two kind of parameters for that. Is one, the sensor itself, the camera itself, if it has an optical zoom or digital zoom, and then the distance from which you're taking that picture. So it depends on how close you can fly. So if you're doing a building inspection kind of straight up and down, you don't want to be, right on it. However, you're looking at what we saw was, centimeter, less than centimeter resolution. And the image, so from, I guess you can get as close as you want zooming in. And then from our traditional aerial mapping is we're looking at inch resolution on the ground from 200 feet altitude that we're taking the images. You're getting some pretty good images. And if you needed super high resolution, that's just a different sensor to strap on, and it's just a different tool for a different job.
We could put different payloads on the drone or on their vehicle, and as an example, we can do thermal imaging. If we put a thermal camera on, we could do that.
Have you guys been denied flight permits? And if so, what reasonings were there?
Yes. It is, so around Logan is one of the bigger spots. There's, I mentioned the 5-mile kind of blanket radius around airports, and that kind of the levels of restriction go along with the complexity of the airspace. And so Logan is really tight with their drone policies. But we're in a process right now to get one of these waivers lifted, or the restrictions lifted for a specific flight. And it's just a process that you go through with the FAA and then also down to the airport. But you work with who you need to work with, and if you've got a good valid reason to fly, people are generally respectful and responsive to that.
And at least in one of those situations where we were denied flight, that just led us to, again, another means and methods. And we were actually able to get the adjacent property owner to give us access to their roof. And we scanned down to the subject from the adjacent roof.
And John, didn't you also strap this onto a wagon?
Yes.
Where we couldn't fly?
We couldn't fly, and I couldn't drive. So I have a garden wagon in my backyard, and I put the scanner on the wagon and walked around the site and filled in. We were able to drive where the roads were, but this was sort of off-road. And with the point cloud, it's called stitching. We take the two different point clouds and stitch them together.
So where there's a will, there's a way.
Very cool. Thank you, gentlemen. Thanks for sharing all of these stories. They've been great and have generated a lot of great discussion this morning. Great way to kick us off. Again, our FMs can join us in FM overtime to continue this chat. And otherwise, we will see you at 11:45 for Zentangling with Janessa, followed by the power of effective change management with Cornerstone Research at noon. So thanks, everyone, and we'll see you soon.